So we're going to have a look at some of the questions from exercise 7.1, starting with question 5, part 1, where we need to expand 1 minus x to the power of 3. Now this is a positive integer power, so I'm just going to use Pascal's triangle, 1, 3, 3, 1 for this, simplest way of working it out. So my first term is 1, I've then got 3 multiplied by negative x, 3 multiplied by negative x squared, and then negative x all cubed. So this gives me 1 minus 3x plus 3x squared minus x cubed for part 1. Now, part 2, find the first 3 terms in the expansion of 1 plus x to the negative 4. So this time, we're going to need to use our generic binomial expansion, 1 plus x to the n, 1 plus nx plus n minus 1 x squared over 2 factorial. So here we go. So this is going to give me 1 plus negative 4 multiplied by x plus negative 4 multiplied by negative 5 multiplied by x squared all over 2 factorial. And this simplifies to give me 1 minus 4x plus 10x squared for the first 3 terms. Now, for what set of values is the expansion valid? It's valid, if we look at the original expansion here, for mod x less than 1, or x between minus 1 and 1. Now, part 3 introduces us to 1 minus x cubed over 1 plus x to the power of 4, which is a combination of the previous parts of the question. So I'm going to take the numerator as it is, but the denominator I'm going to write as 1 plus x to the negative 4, because of course we expanded that in part 2. So that's from part 2 and this is from part 1. So in part 1 we expanded 1 minus x all to the power of 3 and we got 1 minus 3x plus 3x squared minus x cubed, which is now going to be multiplied by just the first 3 terms that we found for the expansion of 1 plus x to the negative 4, which was 1 minus 4x plus 10x squared. Now the question wants us to find out how this result here could be written as approximately 1 plus ax plus bx squared. So that means when we do this expansion on the right hand side over here, we only want to go up to and including the term in x squared, because that's as far as we're taking this approximation. So I'm going to multiply everything in the yellow bracket by 1 first of all, which gives me 1 minus 4x plus 10x squared. I'm then going to multiply everything in the yellow bracket by negative 3x, which gives me negative 3x plus 12x squared. So I'm only multiplying the negative 3x by these terms here, not by the 10x squared, because that will give me a term in x cubed, and I don't need that. And then I'm going to take 3x squared and I'm going to multiply it by the yellow bracket, and I only really need to multiply it by 1 because otherwise I'll go up too many powers up to a power 3. So 3x squared multiplies by 1 gives me 3x squared. So make sure you can understand what I've done there. I've done 1 multiplied by this, and multiplied by this term. I've done 3x multiplied by this term and this term, sorry, negative 3x multiplied by those 2 terms, and then lastly I've done 3x squared multiplied by 1. And I'm going to add these together, which gives me 1 minus 7x plus 25x squared. Now if we compare that to what was given in the question, 1 plus ax plus bx squared, then hopefully you can see from there that the 1 matches on both parts. A must be equal to negative 7 and b must be equal to 25. So moving on to question 6 next of all. So in part 1 we start off with 1 over square root of 4 plus x, which I'm going to rewrite as 4 plus x to the power of negative a half. Now we need to write it in a certain way, so think about what you've learnt previously. Let's leave that power of negative a half alone, but let's take this and let's factorise out 4, leaving me with 1 plus x over 4 in the bracket there. I've still not actually applied this power here. I've only dealt with the 4 plus x and simplified that. So now I'm going to raise both parts to the power of negative a half. So I end up with 4 to the power of negative a half, and then 1 plus x over 4 to the power of negative a half as well. Now, what is 4 to the negative a half? It's a half. So that gives me a half, bracket 1 plus x over 4, all to the power of negative a half. Now, for part 2, they then ask us to find the binomial expansion, the first 3 terms in the binomial expansion of this. So they're not including the half at the start of this just yet. We're just expanding the part in brackets. So 1 over x plus 4 to the power of negative a half. So n is equal to negative a half. And remember, you're replacing x by x over 4. So this gives me 1 plus nx plus n minus 1 x squared all over 2 factorial, at which point I definitely get my calculator out to work out these terms and simplify them carefully. So we end up with 1 minus x over 8 plus 3x squared over 128. Now remember, ordinarily we would then have to make sure we multiplied all of the terms by this half here, but they didn't actually ask us to do this in this question. They asked us to just expand this part over here. We have been asked to talk about validity conditions, so this is valid for mod x over 4 less than 1, which gives me mod x is less than 4, or if you prefer, x is between negative 4 and 4. So part 3, we're then asked to think about this fraction here, 2 bracket 1 minus x over the square root of 4 plus x. So let's rewrite all the parts of this. I'm going to do this in different colours. So we've got 2, we've got 1 minus x, and the denominator, root of 4 plus x, I'm going to write that as 4 plus x to the power of negative a half and bring it up to the numerator. Now, this is interesting. Let's simplify this a little bit further. So here's 2, here's 1 minus x. Now, in the first part of the question, you were asked to rewrite 4 plus x to the negative a half, and we rewrote it as a half, bracket 1 plus x over 4, all to the power of negative a half. Well, look at this. This 2 and this factor of a half cancel each other out, and we're left with 1 minus x, 1 plus x over 4 to the negative a half. Now, we need to find the first 3 terms of this in ascending powers of x. So we're going to use the terms we got from our expansion previously, which was 1 minus x over 8 plus 3x squared over 128, and we're going to do our expansion. So that's 1 minus x over 8 plus 3x squared over 128. I've multiplied everything in the blue bracket by the 1. I'm now going to multiply everything in the blue bracket by negative x, careful, and let's stack the terms. So that's minus x plus x squared over 8. And yes, in theory, we do have to multiply these as well, but we don't need to go up further than the term in x squared because the question only wanted the first 3 terms. So I will stop there. Now let's add these together. So we end up with 1 minus 9/8 x plus 19 over 128 x squared. So question 8, you're now given 3 minus x, 1 plus x over 4 minus x and ask to find a quadratic approximation for this. So I'm going to write this out again as 3 minus x multiplied by 1 plus x, which are the two terms that are already in the numerator. And then instead of 4 minus x here in the denominator, let's make it 4 minus x to the negative 1 in the numerator. Now, here's what I'm going to do. I'm going to expand these two brackets together. So that will give me 3 plus 2x minus x squared. And then we're going to multiply by 4 minus x to the negative 1. But of course, we first of all need to expand 4 minus x to the negative 1 using our binomial expansion. Now notice it doesn't begin with a 1, so there is much work here to be done. Let's rewrite it like that. So all I'm going to do is take 4 minus x, and I'm going to take a 4 out, so it becomes 1 minus x over 4. Now I'm going to raise each part of this to the power of negative 1, so we end up with 4 to the negative 1, 1 minus x over 4 to the negative 1, or a quarter, 1 minus x over 4 to the negative 1. So I'll leave my factor of a quarter in there, and what I'm going to do is now expand 1 minus x over 4 to the power of negative 1 using my binomial expansion here, and I only need to go up to the quadratic term because that's as far as the question wants us to go. So that's 1 plus n times x, where x of course is replaced by negative x over 4, plus negative 1, negative 2, negative x over 4 squared over 2 factorial, and let's simplify. So we end up with 1 quarter plus x over 16 plus x squared over 64. So we now need to revisit the original part of the question from up here, and we need to multiply the expansion we've got here, the 3 terms for this part, by these 3 terms of our quadratic expansion. So we know that 4 minus x to the power of negative 1, the blue part, can be written as 1 quarter plus x over 16 plus x squared over 64 for those first 3 terms, and we only need a quadratic approximation, so we're only going to make sure we go up to terms up to and including x squared and not beyond. So what I'm going to do is take every term in the blue bracket and multiply it by the 3 at the start of the first bracket. So that's 3 quarters plus 3x over 16 plus 3x squared over 64. I'm then going to multiply everything in the blue bracket by 2x. So that gives me, and I'll stack the terms for clarity, so that gives me 2x over 4, and then that gives me 2x squared over 16. I'm not going to multiply 2x by this term because it will give me an x cubed term, which I don't want. And then I'm going to multiply the blue bracket by minus x squared, which gives me minus a quarter of x squared, but I'm not going to multiply here or here, as I'll end up with powers greater than 2 of x. So let's now add these terms together to simplify everything. So this gives me 3 quarters plus 11x over 16 minus 5x squared over 64. For validity conditions, this part here is valid for all x. Remember, that was just a product of 2 very standard binomial terms. And this part here, the blue part, this will be valid for mod x less than 4, which means that the whole expansion here, this result at the end, is valid for mod x less than 4, or if you prefer, x between minus 4 and 4. So let's take a look at question 9. We have a plus bx to the power of negative 3, and we're told it can be approximated by 1 over 8 plus 3 over 16x plus cx squared. And we've got to find A, B and C. So this is really interesting because normally you would be given the numerical values for A and B. So instead, when we do the factorisation of this before we can apply the binomial expansion, I've got to take A out of the bracket rather than a numerical value, which is a little bit trickier. Now this leaves me with 1 plus B over AX here. And we're then going to raise everything to the power of -3. So I have a to the -3, 1 plus bx over a, all to the power of -3. Now, let's leave a to the -3 alone, and let's expand this part here, 1 plus bx over a to the -3. So we're going to use 1 plus x to the n equals 1 plus nx plus n minus 1 x squared over 2 factorial. We don't need to go further than the term in x squared because in the original question we are only asked to go up to the x squared term. So let's do this really carefully. So that's 1 plus n, which is -3, multiplied by x, which is bx over a, plus n minus 1, multiplied by bx over a all squared, all over 2 factorial. Now let's simplify, and then afterwards we'll multiply everything by a to the -1/3. So this is 1 minus 3bx over a, and then we end up with plus 6. Now careful when you're expanding something like this, check you can see what's going to happen. You'll end up with b squared x squared over a squared. Please be careful, there's a 6 and a b involved here and you don't want to get the two things confused. And of course everything has to be multiplied by a to the power of -3, but of course a to the -3 could be expressed as 1 over a cubed, which might make things a little bit easier. So we end up with 1 over a cubed minus 3bx over a to the power of 4 plus 6. And I'm going to do this in a different colour so we don't get 6 and b confused. B squared x squared over a to the 5. Now this has got to be equated with this result that we were given in the question. So this is 1 over 8 plus 3/16 x plus cx squared. And what we have to do is equate different parts of this so we can then work out a, b and c. So really easy to start off with. Look at these two terms here. So it's obvious that 1 over a cubed has got to equal 1/8, which then straight away gives me a is equal to 2. Now I've run out of space, so I'm going to have to shift over onto the next slide. So let's just write that down again. We worked out that 1 over a cubed was 1/8, which tells me that a is equal to 2. So now let me compare the x terms here, and we need to compare their coefficients because that tells me that minus 3b over a to the power of 4 equals 3/16. And I can use the fact that we know that a is equal to 2 to then work out what b is equal to. So cancel the 3's there, and b is equal to negative a to the 4 over 16, which actually works out to give me -1 using this value of a that we worked out. And we then have one last part to process, which is equating these parts here, these coefficients of x squared. So we have 6 multiplied by, and again different colour for clarity, b squared over a to the power of 5 must be equal to c. So that's very easy. We then just substitute in the values that we know for b and a. So c is equal to 6 multiplied by -1 squared over 2 to the power of 5. And this gives us a value for c of 3/16. Now we have to identify the validity conditions for the expansion to be valid. So if you remember, the original expansion was a plus bx to the power of -3, but of course we now know what a and b are, so this is 2 minus x to the power of -3, so this is clearly valid for mod x less than 2. So moving on to question 12, we are given a very interesting question, 4 plus 2x over 2x minus 1, x squared plus 1. And we've got to find the first three terms in the binomial expansion. So here's how I'm going to approach it. There are different ways of doing this. 4 plus 2x I'm going to leave alone. The two parts of the denominator I'm going to make 2x minus 1 to the negative 1, and then the other part x squared plus 1 to the negative 1. So I need to do some expansions here, some binomial expansions. So I'm going to start with 2x minus 1 to the negative 1. So that, of course, is rewritten as this. Now I'm going to need to take out of the bracket here negative 1, which will leave me with 1 minus 2x, and then everything's the power of negative 1. So that then gives me negative 1 to the negative 1, 1 minus 2x to the negative 1, which gives me negative 1 minus 2x to the negative 1. So now I need to expand 1 minus 2x to the negative 1, which I'll do. And this gives me 1 plus 2x plus 4x squared. But of course, everything needs to be multiplied by this negative 1 at the start. So that's negative 1 minus 2x minus 4x squared, just for the first three terms. Now please make sure you've understood what I've done here. We started with 2x minus 1 in this bracket, and I need the rearrangement to start with a 1. So I factorised out a negative 1. Now if you expand back, you can see negative 1 times 1 gives me my negative 1. Negative 1 times negative 2x gives me my 2x here. So it's the same thing. So that's that part, and then the blue part, of course, we could rewrite as 1 plus x squared rather than x squared plus 1. So that's already in the correct format, 1 plus x squared to the negative 1. So that just gives me 1 plus n, and instead of x we have x squared plus n minus 1, x squared, all squared, so our x term has to be squared, all divided by 2 factorial. Simplifying this gives me 1 minus x squared plus x to the power of 4. So I've got my first three terms of this part. I'm then going to go right back up to here, and I'm going to multiply these three things together, remembering I've got three brackets to expand, so there's more work to be done here than normal. So 4 plus 2x, of course, remains the same. Now we have three terms for the expansion of 2x minus 1 to the negative 1, which is negative 1 minus 2x minus 4x squared. And we've just worked out three terms for the expansion of x squared plus 1 to the negative 1, which is 1 minus x squared plus x to the power of 4. So let's go. What I'm going to do first of all is start with the white bracket and the yellow bracket, multiply these together. So I'm going to multiply everything in the yellow bracket by the 4 to begin with. So let's see what we get. We get negative 4 minus 8x minus 16x squared. And then let's multiply everything in the yellow bracket by the 2x, which gives us negative 2x, negative 4x squared. And remember, we only wanted the first three terms, which is the constant term, the x term, and then the x squared term. So I'm not going to bother multiplying 2x by this negative 4x squared here, because that will give me a cubic term. Now, these need to be added together, and then we still need to multiply by 1 minus x squared plus x to the power 4. So we haven't done the blue part yet. Let's simplify the product of the first two brackets first of all, which is negative 4 minus 10x minus 20x squared. And the blue bracket is 1 minus x squared plus x to the power 4. Now, multiplying these together, let's see what happens. We're going to multiply everything in the blue bracket by this negative 4 that I've underlined in yellow. So negative 4 plus 4x squared, and then we can stop there because we'll then end up with a power of x to the 4, which we don't want, so we won't multiply there. Negative 10x can only be multiplied by the 1 here. So otherwise we'll end up with powers of x cubed, which we don't want. And then negative 20x squared, again, can only be multiplied by the 1 there. So adding these together gives us minus 4 minus 10x minus 16x squared. Now, as for validity conditions, we need to go back up to here and look at these two expansions for that. So 2x minus 1 to the power of negative 1 is valid for mod x less than a half, or x between a half and negative a half. And then the one next to it, which is x squared plus 1 to the negative 1, well, this is valid for mod x squared less than 1, which means that x has got to be between 1 and negative 1 if you want the magnitude of x squared to be less than 1. Now remember, we always go, if there's a choice of inequalities, we go for the stricter one, and the stricter one is that x has got to be between minus a half and half. So the overall validity condition is this: x has got to be between negative a half and a half.